Hello. So welcome back. We are going to continue looking at probability, and today we're going to be focusing on compound events. So I'm going to start off with a couple of definitions for you, and then we're going to work through a couple of problem examples for you to practice. So in compound events, the definition is, we can just fill in right here, a compound event it's an event that's made up of two or more simple events. So that's the really important part, is that it's of two or more. And then we are going to look at specifically first something called mutually exclusive events. So mutually exclusive events are events that cannot both occur in the same trial. So that's pretty important. Cannot both occur in the same trial of an experiment. For example, if I had a die, I could not roll a 1 and a 2 on the same roll of the number cube. So that's why that's considered something called mutually exclusive. And so I have a chart here for you to reference that gives you three types of variations of this. So it's written in words. The probability of two mutually exclusive events, A or B, occurring is the sum of their individual probabilities. So that's going to be really important because we're going to be adding the sum. In algebra, for two mutually exclusive events A and B, you would see it written like this: the probability with a parentheses and then A, and then this symbol is a union symbol, and I referred to this down here just to recall that the union symbol U means or. And so what that means is to add your probability of A plus the probability of B together. And then this is an example. So when rolling a number cube, we want to know when we have the probability of less than 3. So that means the numbers 1 or 2, right? So the probability of rolling a 1 would be 1/6. The probability of rolling a 2 would be 1/6. So when we add those together, you get 2/6, which simplifies to 1/3. So we're going to run through two examples just so you can see how this works. So in example 1, we have a drink company that applies on label of each bottle cap, can't talk this morning, free drink, free meal, or try again. So you know, like when you open up bottles of soda, when you flip open the cap, you can see that sometimes they have promotions written on there. So this is an example of that. A bottle cap has a 1/10 probability of being labeled free drink. So I'm just going to underline 1/10 and free drink. And then in another color, I'm going to say that it has a 1/25 probability of being labeled free meal. So we are asked to find what's the probability that a bottle cap is labeled free drink or free meal. So we are going to just first use our notation. So probability of free drink or, we're going to use that symbol, the U, or a free meal. So that means that we're going to first find the probability of a free drink. Well, they told us that in the problem, that it was a 1/10 probability. So that's going to be 1/10. And we're going to add the probability of a free meal. So free meal, we were told, was 1/25 of a free meal. So it's 1/25. So we need to add these fractions together. So we need to make sure that they have common denominators. So if I'm thinking of 10 and 25, my common denominator would be 50. So I'm going to change these denominators to 50, but then I need to also change my numerator. So I'm going to do this in a different color. So I know that I would need to multiply this by 5. So that means that this numerator becomes 5. And then for 25, I would multiply by 2. So I get 2/50ths. So then I just simply go ahead and add, and I get an answer of 7/50ths. And that would be my probability of getting a free drink or a free meal. Okay, so if you would, just go ahead and pause the video and try example B on your own and see how you do. Okay, so in example B, a group of students is donating blood during a blood drive. A student has a 9/20ths probability of having type O blood and a 2/5 probability of having type A blood. We want to know what's the probability that a student has type O or type A. So again, we're just going to write this as the notation. So the probability of someone having O type or A type. So we go back to the problem. It tells us that someone that has O-type blood is 9/20ths. So that's going to be 9/20. And then we're going to add what A-type blood, so that would be 2/5. So that would be 2/5 here. All right, then we need to find out what our common denominator is. So between 20 and 5, 20 is going to be our common denominator. So that's going to be 9/20ths plus, and then we've got 20 as our denominator here. So I would need to multiply 5 times 4 to get my new numerator. So that's going to give me an answer of 8. So then I can go ahead and add horizontally. So I get 17/20. And that can't be simplified, so that would be my final answer, 17/20. Okay, all right, so those are considered mutually exclusive. Now what we're going to be looking at is something called overlapping or inclusive events. So I provided a little definition for you here. So we're going to say these are inclusive events. Sometimes you'll hear them being referred to overlapping, and we'll look at why. These are events that have one or more outcomes in common. For example, when you roll a die or a number cube, the outcomes of rolling an even number and rolling a prime number are not mutually exclusive, which means that you could have overlapping outcomes. So, for example, the number 2 is both even and it is prime. So those events are considered to be inclusive or overlapping. So again, I provided you with a table that shows you in words, in algebra, and as an example. So we have the probability of 2 exclusive events, A or B, occurring is the sum of their individual probabilities minus the probability of both occurring. And so algebra, we have this here. We've got the probability of this occurring, which is the definition, A or B. So the probability plus A plus B. But then we want to subtract the probability of A and B also occurring. So when you roll a number cube, if you're looking for even number or prime, you're looking for even or prime. So the probability of an even would be 3/6. The probability of prime would be 3/6. And then you would subtract when you have an overlapping, so an even and a prime, which would be that 2. So you end up with an answer of 5/6. And again, recall that the union symbol, I don't think my highlighter is working. Recall that the union symbol with an upside down U means and. So both of those have to happen. All right, so let's take a look at an example. So this makes a little bit more sense in the context of a problem. Okay, so we're asked to find the probability on a die of rolling a 5 or an odd number. So what I find helpful is actually to make my sample space. So I'm going to just draw kind of like a box here that has all the different outcomes on a die. So I know that there's 6 numbers on a die, right? 1, 2, 3, 4, 5, and 6. And if I'm asked to find the probability of rolling a 5 or an odd number. I'm going to take a look at what I've got here. So probability of 5, well, that would be 1/6, right? And then I've got the probability of an odd, so I'm going to circle my odd numbers. 1, I got a 5 again, and a 3. So if I look at how many I have here, 3 numbers are circled out of my 6. So I could just simplify that to be 1/2. So I find that these are actually a little easier than the mutually exclusive ones. All right, so go ahead and pause your video and try example 2B on your own, and then you can unpause and check your answer. Okay, so in part B, a card is drawn from a deck of 52. So in a standard deck of cards, there's 52 cards. Find the probability of drawing a king or a heart. So the probability of drawing a king or a heart. So in my probability of doing this, I know that I have 4 kings in a deck of cards, right? So that would be 4 out of 52. And then with my hearts, I know that there are about a quarter of the deck, right? Or 13 out of the 52 are going to be hearts. But also remember that a king, one of those kings, there is a king of hearts. So I have to get rid of that king of hearts. So I'm going to add these two, but then I have to subtract the 1 king of hearts that I have. So I'm going to take the 1 out of 52 here. And then I'm going to go ahead and go across. So I've got 4 plus 13 is 17, minus 1 is going to be 16 out of 52. And then I look and see if I can simplify that. So I could divide that by 4. So that would give me an answer of 4, and that would give me an answer of 13. So my final answer would be 4/13 would be the probability. All right, so you have some practice to complete on IXL, and this will go over both mutually exclusive and inclusive or overlapping events.